Today we are going to study chemistry, and in that we were studying the important topic so called as aliphatic hydrocarbon, and this is session number 4 belonging to the same chapter. Now in session number 1, session number 2 and session number 3 we were dealing with an important topic so called as alkane. We studied the general formula for alkane and up to 5 members. We studied how the molecular formula will be there and how the structure formula will be there. Then followed by that we studied the preparation of alkane by adapting the different process. In those 3 sessions we winded up with the alkane topic over there. Right, now we'll start with the new topic of this same chapter, which is alkene. Right, so first one we have been completed the first compound which was belonging to the aliphatic hydrocarbon was alkane, which was containing carbon-carbon single bond, and that was basically saturated hydrocarbon. Alkane was a saturated hydrocarbon. Now let's begin with a new concept which is so called as alkene. Now alkene is also aliphatic compound because it's a straight chain compound, right? But here it is considered to be unsaturated hydrocarbon, unsaturated aliphatic hydrocarbon in fact. Why? Let's see what is the reason which is making it unsaturated. Let's see over here. Now alkene is an aliphatic unsaturated hydrocarbon. Alkene is aliphatic unsaturated hydrocarbon containing most important point over here, containing one or more double bonds. One or more double bonds are called as alkenes. Alkenes are also called as olefins. Alkenes are also called as olefins. Now what do you understand by this statement? Alkenes are aliphatic hydrocarbon, but they are unsaturated aliphatic hydrocarbon containing one or more than one double bond between the carbon atom and the skeletal. Right? So here the double bond will be present between the carbon-carbon atom, whereas in alkane single bond was there. That's why it was converting into the saturated, whereas this is unsaturated person. Right? So alkenes are also called as olefins. Alkanes and alkenes, the huge difference between alkanes and alkenes are there. Both are coming under aliphatic hydrocarbon, but in alkane it was saturated aliphatic hydrocarbon. In alkane it is unsaturated aliphatic hydrocarbon. The reason is that in alkane it was containing single bond in the skeletal structure, whereas in alkane it may contain more than one double bond into the straight chain or skeletal carbon chain over there. Right, so let's talk about this alkene in more detail and how many number of members are belonging to alkene. What is the general formula for this alkene? Let's go for that. Now alkene is having basically the general formula so called CnH2n. Right, so this is the general formula for alkene. So alkene is having a general formula with the CnH2n. Right, so depending upon this general formula we are going to study the 5 members, the first 5 members of alkene family. How we studied the first 5 members belonging to the alkane family. Similarly, by adapting this formula we are going to study the 5 members belonging to the first 5 members belonging to the alkene family. So hereby we start with the first member of an alkane. Now alkene will have the first member with carbon 2. Carbon 2, right? So here one more thing which I would like to say over here is the N stand for, what does the N meant by? N stand for number of carbon atom. Number of carbon atom present into it. Carbon atom. That may be 1, 2, 3 and so on. Right, so it depends upon the number of carbon atom present into that compound. The N will keep on differing over there or varying over there. Right, so let's begin with the first member of alkene family. So that is carbon number 2. Here alkene family will not begin with the carbon number 1. Remember, in alkane it was starting with the carbon number 1. Right, the methane was the first member for that family, whereas in alkene there is no such molecule which is with the carbon number 1, it will becomes the member for that family. So thereby carbon number 2 means we will substitute N as a 2 into that formula, and thereby whatever will get that compound, that will become the first member of the alkene family. Now if carbon 2 is there, that means N will be 2, right? So if N is 2, now let's substitute that N with 2 into that formula, general formula. The general formula was CnH2n, right? So this is a general formula over here. Now let's substitute N with the 2 over there. Then we are going to get one molecule or the compound. Okay. So let's substitute here. So C2H2 into 2. So this becomes C2H4, right? So this is the molecule whose name is first molecule belonging to the alkene family, and the name of this compound is basically called as ethene. So ethene is having a molecular formula so called C2H4. So this is the molecular formula of ethene. Ethene is becoming the first member of alkene family. Now let's draw the structure for this. Now how many carbon are there? Let's draw first the number of carbon over there. Now after writing down the number of carbon over there, then the number of hydrogen is 4, right? So in alkane it was becoming like this. With one bond in between them, carbon, and 4 hydrogen we will substitute like this. But in alkene, it being unsaturated, here the structure will going to get differ. It will possess carbon-carbon double bond between them, and totally how many hydrogen is there? 4 hydrogen will be there. Sorry, in alkane I'll just say you once again. In alkane the structure was like this, okay, with one single bond, and 3 bond will be there for binding with the hydrogen atom over here. But since now the double bond will be present between the carbon-carbon atom, now the structure of the alkene will be going to become like this, right? So I'll draw once again, then it becomes more clarify over here. So carbon, double bond carbon, but how many hydrogen is there? 4 hydrogen. Now 2 over here, right? So this becomes the structure for ethene. Now if this is the confusion which is arising over there, what you need to do is that we know that carbon is having valency of 4, that means it can bind only with the 4 other atoms over there, right? Now one bond is already utilized for getting combined with the another carbon atom. Now here one more bond is going to get bind up with the other carbon atom, because in alkene we said it is an unsaturated hydrocarbon. So the double bonds are utilized over to get bind with the 2 carbon atoms, right? So each carbon will share these 2 bonds over there, right? So this carbon, let's count the number of bond over there. 1, 2, 3, 4. This is balanced. Now the carbon number 2, let's see here. 1, 2, 3, 4, right? So this becomes the structure for ethene, right? So this becomes the structure for ethene. Now let's go towards the second member of the alkene, second member which is belonging to the family so called as alkene, with carbon 3. 3 number of carbons we are going to draw over there or write over there in the straight chain. So N will be going to get substituted with the 3. So the formula was CnH2n. This is a formula. Then let's substitute the N as 3 over here. So N is 3. H is equal to, H is nothing, here is becoming 2 into 3. Right? So this becomes C3H6. C3H6. And the name for this compound is propene, right? So this is the second member of the alkene, which is propene. The name is propene. Okay, so the name for this is propene with the molecular formula C3H6. C3H6. So let's draw the structure for this. the structural formula with the molecular formula C3H6, so called as propene. We are going to draw the structure for it. So how many carbon is there? 3 carbon. So let's write down the 3 carbon like this in this manner. But we know that between the carbon, 2 carbon atoms, 1 double bond should be there, right? At presently we are talking about the 1 double bond. Later on you may get more than 1 double bond, right? So here now I am going to draw 1 double bond between carbon number 1 and carbon number 2. Now carbon number 3 I am going to write down as it is, right? So remaining carbons I am going to satisfy by substituting with the hydrogen atom over there. So here how many total? This is carbon number 3. So 4 bond will come to this carbon number 3, right? So here 1, 2, 3, 4, correct? So 4 bond, because since it being a terminal one, here no double bond is present over here. So this carbon will be going to get balanced with the 4 bond over here. 1 bond is already getting linked up with the neighboring carbon atom over there. So this becomes the terminal carbon with 3 hydrogen atom attached to it. Now let's talk about the carbon number 2. Now in carbon number 2, we know that carbon number 2 is going to get attached with the carbon number 1 by having double bond between them, right? So already how many bond is there with the carbon number 2? 1, 2, 3. So only 1 bond it can get bind up with the hydrogen, right? Whereas in carbon number 1, here already 2 bonds are there, 1, 2. So how many two more bonds are going to get attached with the carbon number 1? So this becomes the structure for propene. Let's count the number of hydrogens. 6 hydrogens are there. So here is it 6 hydrogen is there? 1, 2, 3, 4, 5, 6. Done. So the name for this structure is propene. In means double bond. But between which carbon atom? Between 2 carbon atoms the double bond is present. Which are those 2 carbon atoms? Carbon number 1 and carbon number 2. So we are going to take carbon number 1, the lowest preference we are going to utilize over here with 1 and then in. That means between carbon number 1 and carbon number 2, the in is present. In means the double bond is present, and that's you we need to give the lowest preference number over there. So the lowest preference number between carbon number 1 and carbon number 2 is 1, because 1 is lower than 2, right? Smaller than 2. So we are going to take the lowest preference over there. So this is 1, right? So I am going to write down 1 over here, right? So this is how the structure will be there for propene. Now let's go towards the third member of alkene family. Now it has 4 carbon atoms, and thereby N will be substituted with 4. And the general formula, as we know that it is CnH2n, right? So I am going to substitute N with the 4. So this becomes 2 into 4, and this is C4H8, right? So this is the molecular formula for the next compound whose name is butene, right? So this is the name of the 4th member of alkene family. Now let's draw the structure for this butene, and then you will understand more precisely over here. Now it has how many carbon over there? 4 carbon and 8 hydrogen. So let's draw the 4 carbon over there. So 4 carbon I am going to draw one by one. 1, 2, 3, 4. Done? Okay. Now in alkene we know that double bond will be there. Now I am going to draw this double bond between now let's number the carbon chain over here. 1, 2, 3, 4. I wanted to draw that double bond between carbon number 2 and carbon number 3. So I am drawing this double bond in between carbon number 2 and carbon number 3. Okay. Now let's balance that each carbon by getting binded with the number of hydrogen atom which is present into that molecular formula. Now this carbon number 1 being a terminal carbon, it will have 3 bond which will be going to get attached with the 3 hydrogen atom, because 1 bond it is already attached with the carbon number 2 neighboring carbon atom. So this becomes hydrogen, right? So 3 hydrogen atoms will be going to get bind up with the carbon number 2. Now let's talk about the carbon number 1. Let's talk about the carbon number 2 over here. Now in carbon number 2, already 2 bonds are there which has been attached to the neighboring carbon, which is carbon number 3. So 1, 2, and here one more is there, 3, right? So 1, 2, 3, and one more will be going to get attached with the hydrogen. This is how you need to balance out the valency for the carbon. Each carbon can bind up only with the 4, or it can make only 4 bonds to get bind up with the another atoms over there, right? So carbon number 2 will be going to get balanced in this manner. Now let's talk about the carbon number 3. Here also this double bond will be going to get shared up between carbon number 2 and carbon number 3. So here 1, 2, 3, right? This one is also belonging to this carbon number 3, right? So one bond it is remaining, and it will be going to get bind up with the hydrogen atom. Now let's talk about the carbon number 4. It being a terminal carbon, terminal means end carbon, it can get attached with the 3 hydrogen atom. 3 hydrogen atom, because one bond is already attached to the carbon number 3 over here. So 3 hydrogen atom it can bind up with it. So this is how the structural formula for the butene will be there, but the name will be going to get varied. Why the name will be going to get varied? Let's see over here. How many hydrogen is there? Totally 8. So let's count 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 hydrogen, 4 carbon. Done according to the molecular formula. But the name for this structure will be going to get varied, because here you can see that the double bond is present between carbon number 2 and carbon number 3. So depending upon the presence of the double bond into the skeletal straight chain carbon atom, the name will be going to get differ over here. Now since it is present between the carbon number 2 and carbon number 3, the name will become as but. Now in is double bond, right? But it is present between carbon number 2 and carbon number 3. The lowest preference for it is 2. Right? So but 2 in. So this is the IUPAC name for this structure, right? So but 2 in becomes the name for this structure with carbon number 4 and hydrogen 8. Carbon 4, hydrogen 8, right? So you need to remember this, depending upon the position of the double bond between the carbon atoms, the lowest preference you need to choose, and you need to write down that in the middle before writing down in over there. In means the double bond, the position of double bond. So between carbon number 2 and carbon number 3, the in was present, but we are going to choose the lowest preference, which is 2. So but 2 in becomes the name for this structure. Okay, now let's go towards the another carbon. Right, another member, in fact another member of the alkene family with carbon 5, okay. Now if I am taking carbon as 5, this is 4th one. If I am taking carbon 5, the N will be going to get substituted with the 5 over there, and we know that the general formula for this is CnH2n. Now I am going to substitute N with the 5 over here. N is 5, so 2 into 5. So this becomes C5H10. C5H10. So this is the next member of the alkene family with the molecular formula C5H10, and the name for this is pentene. Okay. Now let's draw the structure of this, with the molecular formula C5H10. So how many carbon is there? 5 carbon. So let's draw this 5 carbon in the straight form. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay. Now I want to substitute the double bond between carbon number 2 and carbon number 3. Okay. Carbon number 2 and carbon number 3. Since if I am going to see, numbering of the chain is also very, very important over here. Numbering of the chain also very, very important over here. Now wherever the double bond will be there, right? Nearer to that only the numbering should start. I cannot start the numbering of the chain from the back side, because if I start from the back side, it will become like 1, 2, 3, 4, 5. It is present between carbon number 3 and carbon number 4. Suppose if I am starting with the front side, right? Forward direction 1, 2, 3, 4, 5. So it will be present between 2 and 3 from forward direction, but we are taking it from the backward direction, it becomes 3 and 4. So the pairing which is having lowest pairing, that we need to choose. So this is it. So this is all IUPAC nomenclature, but I want you to understand from the basic only, then it becomes very simplified for you guys to understand during the preparation method, right? So this numbering is very, very important while writing down the chain. Along with that, while naming also it is very important over there. So 5 carbon atoms I had drawn over there with the double bond situated between carbon number 2 and carbon number 3. Now let's balance this by drawing the number of hydrogen atom which needs to be get attached with the carbon atoms over there. So I am just writing down downside. It becomes very easier for us to draw the number of hydrogen atom over there. Now carbon number 1, since being it is present in the terminal, we know that here 3 bond will be present, because 4th bond it is already attached to the another carbon. So let's satisfied with the number of hydrogen atom. Now carbon number 2, since already 2 bonds are there which is attached to the carbon number 3, 1, 2, 3, 4, only 1 hydrogen will be going to get attached. Carbon number 3, 1, 2, 3, 4. Done. Now 4th carbon, 1, 2, 3, 4, and this is 1 is there, 3 will be there, right? So this is how the structure of pentene will be, but the name will be going to get differ, right? Let's count the number of hydrogen first and then we'll write down the name for this. So totally 5 carbon should be there, 5 carbon is there, 10 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 hydrogen is there, and the name for this is pent. Now in is present between which 2 carbon? Carbon number 2 and carbon number 3. Lowest preference is carbon number 2, means lowest numbering you need to take. So carbon number 2 it is present, right? The lowest preference will be 2. So pent 2 in. Right, so this becomes the name for this compound. Okay, now suppose if the double bond was present between carbon number 3 and carbon number 4, right? It is present between carbon number 3 and 4, then the numbering would be 1, 2, 3, like this. If it is present from back side, the numbering will be like this, back side. That way you need to remember over here, right? Okay, now let's go towards the another one. The 5th carbon over, now the 6th carbon atom will go towards that by substituting an S5 over there, right? So let's talk about the next carbon or the next member belonging to the alkene family. Okay, now 5th one with C has 6. C has 6. And N we are going to substitute as 6, and we know that the general formula for the alkene was CnH2n, right? So if this is the general formula for this alkene, let's substitute the N with the 6, okay? Then this 2 into 6, this becomes C6H12. So this is the molecular formula for the next member of the alkene family, and the name for this is hexene. The name for this is hexene, right? Now 6 carbon is there. Let's draw this 6 carbon. 1, 2, 3, 4, 5, 6. 6 carbon is there. 1, 2, 3, 4, 5, 6. Okay. Now I want to substitute. I want to give the bond, double bond between like here. Now let's start numbering this. Carbon number 1 and carbon number 2. 3, 4, 5, 6, right? Suppose if I am taking from forward direction, the numbering if I am taking from the forward direction like this, right? So what will happen? Here 1, 2, 3, 4. 4 and 5. The double bond will be going to get present between 4 and 5. Carbon number 4 and 5. So lowest pairing we need to choose, that is 2 and 3. That's why the numbering I had given from the backward direction. Okay. So then now substitute by balancing the valency of carbon atom. We are going to substitute the number of hydrogen atom over here. Now carbon number 6 will have 3 hydrogen. As we know, it is a terminal carbon. 3 hydrogen will be present. Now carbon number 5, already 2 bonds are there which are going to get linked with the neighboring carbon atom in the straight chain. Then it will going to get bind only with the 2 hydrogen atom. So 1, 2, 3, 4. In this manner it will be going to get balanced with the 4 valences. Carbon number 4 will also have 2 hydrogen atom over there. Now let's talk about the carbon number 3. Here already 2 bonds are there and 1 bond it is attached to the carbon number 4. So it will have only 1 hydrogen atom which is going to get bind up with the carbon number 3. So in this manner 1, 2, 3, 4 it is going to get balanced out by having 4 valency over there. Now carbon number 2 will also have 1 hydrogen atom, because 1, 2, 3, 4 like this. In this manner it will be going to get satisfied, and the carbon number 1 being a terminal, it will be going to get attached with the 3 hydrogen atom, right? So this is how you need to understand while drawing the structure for that particular compound with the molecular formula C6H12. Okay, now let's count the number of hydrogen atom. Basically 6 carbon is there, means 12 hydrogen should be there, double of it, right? So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Done. So this is how you need to draw the structure, and this is the structural formula for hexene. But the name will be going to get varied, because depending upon the position of the double bond between the carbon-carbon atom, the name will be going to get varied over here as hex. Hex, between which 2 carbon atoms the in is present, the double bond is present between carbon number 2 and carbon number 3. Lowest preference what I am going to take? 2. So hex 2 in. Okay. So this is how the structural formula will be there for hex 2 in. Right. So these are the 5 carbon atoms. We know that there carbon number 1 with N substituting 1, we don't have that kind of a compound. So directly you need to begin with the carbon number 2, carbon as 2, and substituting N as 2 will get the first member of an alkene, which is ethene. So let's write down those 5 members wherein we have been studied over here in alkene family one by one. So the first member of the alkene was ethene. Okay. The first member of an alkene was ethene. The second member of the alkene was propene. The third member of the alkene was butene. The fourth member of the alkene was pentene. The fifth member of the alkene was hexene. So these are the first five member of the alkene family, and with the into that, and depending upon the position of the double bond, the in will be going to get varied. Means if it is present between carbon number 2 and carbon number 3, the lowest preference you need to choose over there and write down the name of that compound accordingly. Right. So what was an alkene? Alkene was nothing but it was aliphatic unsaturated hydrocarbon containing one or more double bond between the carbon atoms. Right. So that was the definition for alkene, and then we studied the first 5 members belonging to the alkene family having a general formula so called CnH2n. How many carbon atom will be there? That much double will be the hydrogen atom, because the general formula only it is saying. Right. So that much double the number of hydrogen atom will be there, and accordingly you need to draw the structure for it, and depending upon the position of that double bond, the name will be going to get varied over there. So this is how you need to remember the alkene with the first 5, and the remaining 2 more members you need to draw the structure with the molecular formula, appropriate molecular formula, and then These structures should be drawn by you guys. That is the homework for you guys. Now the next topic we are going to study over here, the preparation method. This is really very interesting. So before starting the preparation method only, I started by taking the basic 5 elements or the 5 members belonging to the alkene family. If you came to know with this 5 members, it becomes very easy for you guys to study the preparation methods, right? So in the preparation method, you are going to study how the alkyl will be going to get prepared by taking certain to another reactant, and the reactant will be depend upon the process wherein we are going to adapt for the preparation of alkene or olefin over there. Okay, now we'll start with the next topic, which is the preparation methods. Now in this methodology we are going to prepare alkene, the olefin, by taking certain process or by adapting certain process over there. Now the first reaction we are going to start with it is the elimination reaction. Now in this elimination reaction, the sub concept over there is via dehydration of alcohol. Dehydration of alcohol, we are going to prepare the alkene. Now what do you understand by the word dehydration of alcohol? D means removal. Remember this word. D means removal. Removal of hydration means what? Here the water molecule will be going to get removed. So D means removal. Removal of what? Hydration. Hydration means what? Water. So the water molecule will going to get removed off from where? From alcohol. So you are going to withdraw or remove the water molecule from the alcohol group, right? So after removal or the elimination of water molecule from the from the alcohol, you are going to obtain an alkene. I repeat once again. By removing water molecule from this alcohol, you are going to obtain the alkene. So this is the process which is called as elimination, right? So what is happening over here? The reaction in which compound containing carbon-carbon single bond, right? The reaction in which the compound is containing what? Carbon-carbon single bond are converted into carbon-carbon double bond by elimination of atoms or group from adjacent carbon atoms is called as beta elimination. Now what do you understand by this full definition? It's very simple, children. Here what is happening is that from alcohol, now alcohol will have certain functional group. You need to understand that functional group wherein you have been already studied in your 12th standard. The functional group for alcohol will be ROH. So this is the functional group for alcohol. Now R stand for what? R stand for alkyl group, right? So alkyl group may be ethyl, methyl, propyl, anything, right? So if I am taking ethyl, as the alkyl group, here carbon-carbon single bond is there, no? Right? So from alcohol which is containing carbon-carbon single bond and OH is going to get attached to it as a functional group. So in this alcohol, carbon-carbon single bond is there. That carbon-carbon single bond will be going to get converted into carbon-carbon double bond by elimination of water molecule. By elimination of water molecule from it. Right? So what do you understand by over here? The alcoholic group which is containing the carbon-carbon single bond, it will be going to get converted into the carbon-carbon double bond by elimination of water molecule from the adjacent carbon atom over there. So if 2 carbon is there, from one carbon OH group will remove, from another carbon hydrogen group will be going to get removed off, and they are going to get combined together to form a water molecule. How they are going to get withdrawn? Let's understand that by taking the general reaction and by taking the example. So this is the beginning of that topic. Very simple, children. What is happening over here? Here the saturated compound is getting converted into unsaturated compound, means the alcohol which is having carbon-carbon single bond, it is going to get converted into carbon-carbon double bond simply by the elimination of water molecule, and that elimination of water will be going to take place in such a manner that one carbon atom will remove hydroxyl group. means the OH group will be there, no? The one carbon will remove the hydroxyl group, another carbon will remove the hydrogen group. So water is containing what? Water is containing 2 hydrogen and 1 oxygen, right? So hydroxyl group will be going to get obtained from where? From here, because the alcohol will have a functional group as OH, right? And another hydrogen from where we are going to get? The neighboring carbon atom, right? So that neighboring carbon atom will withdraw the hydrogen atom, and thereby we are going to get eliminate the water molecule from the alcohol to obtain alkene, which is a olefin also, right? So this is what the dehydration means. You are going to dehydrate the alcohol, right? So alcohol will going to withdraw the water from it, eliminate the water from it, and thereby you are going to obtain the alkene over here. So that was the meaning for that statement. Whatever the big statement was there, that is the meaning. But now why it is called as a beta elimination? Let's understand. Now here beta elimination it is called because specifically from beta carbon atom the hydrogen atom will be going to get removed off, right? So let's understand that how that beta elimination take place. So we'll understand by taking the general reaction over here. General reaction. So by adapting this general reaction, you'll understand more precisely over there. Now general reaction, this is the alcohol group, right? So one will be the alkyl group. Obviously alcohol is having the functional group so called like this, right? So I am taking the alkyl group with the 2 carbon. Alkyl group I am obtaining with the 2 carbon. If 2 carbon is there in the alkyl group, which name we are going to get adapted? Ethyl, right? Ethyl. Remember, alkyl group and alkane group, they are the sisters for each other, because in alkane hydrogen is there. If one hydrogen becomes less, it is going to get converted into alkyl. Our group is considered to be the alkyl group. Now in place of hydrogen we have been substitute with what? Hydroxyl. So the name will going to get converted as alcohol. This is alcohol, this is alkane. Do not get confused between these two, right? So alkane will have the functional group so called as RH, alcohol will have the functional group so called as ROH, right? So in both alkyl group will be present, right? So this is how the functional group will be going to get named accordingly. Now this is the general reaction we are going to study over here. Now what we studied, that dehydration of alcohol should take place. Dehydration means removal of water from alcohol. Now here there are 2 carbon atoms, carbon 1 and carbon 2. Now carbon 1 is considered to be the alpha carbon, carbon 2 is considered to be the beta carbon. Now why carbon 1 is considered to be the alpha carbon? Because alpha carbon will be that carbon atom to which the functional group will be attached, right? So alpha carbon is considered to be that carbon atom to which the functional group is attached. Now OH is a functional group which is attached to the alpha carbon, and neighboring to alpha carbon will be the beta carbon. Understood? So this is what the naming of the carbon will be done, alpha carbon and the beta carbon. Okay. Now here the dehydration will be going to take place. Now if the dehydration is going to take place, certain dehydrating agent should be added into it. Now here the dehydrating agent they are going to add over here is sulfuric acid. In certain proportion they are going to add the dehydrating agent that will help out to break the bond between the hydroxyl, the OH group and the carbon group with the hydrogen group, right? So here what will happen, the water will be going to get removed off. We know that water will be going to get removed off. Now how the water will be going to get removed off? Because from alpha carbon atom hydroxyl group will be going to get removed, and from beta carbon atom the hydrogen will be going to get removed, right? So this is how the elimination is taking place. I repeat once again, from alpha carbon atom the hydroxyl group will going to get removed off, and from beta carbon atom, this is a beta carbon atom from which the hydrogen will be going to get removed off. So these two will be going to get combined together to form H2O, which I written over there, right? So what is left over there? The remaining thing. The remaining thing, once the bond is broken over here, then it will be going to get converted into the double bonded compound, which is called as the first member of the alkene, which is the alkene. Which is the name of that alkene? Ethene, right? Ethene will be the name of it. I repeat once again, here what is happening, from alpha carbon atom the hydroxyl is going to get removed off, OH group. From beta carbon atom the hydrogen is going to get removed off. Once the bond is broken over here, the new bond will be going to get formed over there between the alpha carbon and beta carbon, and thereby the definition was saying the single bonded carbon-carbon atom will be going to get converted into double bonded carbon-carbon atom, right? So saturated carbon atom is going to get converted into unsaturated alkene, right? So this is how the alkene will be going to get formed by dehydration, removal of water from the alcohol, right? So that is the general reaction. Let's take the example, then you'll understand more precisely over here. This was the first general reaction. Let's take the example for over here with the 3 carbon atoms, 1, 2, 3, right? So these are the 3 carbon atoms which I have written in the straight form, and which alcohol we are going to take. The 3 carbon oriented alcohol will be named as propanol. The name will be propanol, right? So it depends again on the position of alcoholic group over there. The name will be going to get varied over there. Suppose if the alcohol group is present in second carbon atom. Now let's draw the structure full, then you'll understand more precisely over here. Now if in second carbon atom, now if I start from here, chain 1 numbering as 1, 2, 3, okay. Now if in second carbon atom the OH group is present, then it is named as propane. Parent alkane will be propane, right? Parent alkane will be propane, but E will be going to get erased out, and in place of that E, the OL group will come. The OL, alcohol, right? OL. So OL group will come, but the OL group is present between whom? In carbon number 2. Not between, it is attached to carbon number 2. If double bonded is there, that time we have to say it is present between carbon number 2 or carbon number 3 or somewhat like that. But if it is specifically present or attached to certain carbon atom, specific carbon atom, we are supposed to give that number only, right? So it is present at carbon number 2. The OH group will be present at carbon number 2. So its name will be propane 2-ol, like this. The name will be there, propanol. But all group is present between in carbon number 2. So thereby the name will be that. Now here, what is going to get happened over here? Yes, the elimination reaction means dehydration is going to get happen in alcoholic group. Now dehydration means what? Yes, removal of water molecule. Now how the removal of water will be going to take place? Now alpha carbon atom will be considered as that carbon atom which is attached to the functional group. The functional group is OH. So carbon number 2 is considered to be the alpha carbon, and the neighboring 2 carbon will be considered to be a beta carbon, right? So this is beta 1 and that is beta 2, right? So let's take the beta 1 and this is beta 2. Okay. Now from alpha carbon atom, the OH group will be going to get removed off, and from beta, let's take one beta group over here. From beta carbon atom, beta 1 carbon atom, the hydrogen group will be going to get removed off. Okay. Now here, if the hydrogen is getting removed off from beta 1, and from alpha the hydroxyl group is going to get removed off, and this is going to get removed off in presence of an agent which is called as dehydrating agent, and name of that is sulfuric acid. The name of this dehydrating agent is sulfuric acid. Now once this hydrogen group and the hydroxyl group is removed off, they are going to get combined together to form water molecule, right? So they are going to combine together to form water molecule, H2O. Then the remaining what is left over here, the molecule will be going to resemblance in this manner, CH3, okay, CH3 and then CH. Now this bond has broken and this bond is also broken. Then the new bond is going to get formed over here between carbon number 2 and carbon number 3, and that will be the double bond, right? And with one two hydrogen will be there. One hydrogen has been removed, right? So carbon number 3 will have 2 hydrogen and carbon number 2 will be having 1 hydrogen. You can see over there from the structure only. So I'm going to write this hydrogen over here. 1 hydrogen it has removed over here, right? So the name of this alkene or olefin which has formed over there is 1, 2, 3. So with 3 carbon atom, what will be the name of the alkene? Exactly, propene, right? So in. Now in is present between whom? Carbon number 1 and carbon number 2. So what is the lowest preference over there? Carbon number 1, right? So prop 1 in will be going to get obtained when the alcohol will be going to get removed off the water molecule from that, right? So when the propane 2-ol is treated with the dehydrating agent, that time the water molecule will be going to get removed in such a way that the alpha carbon atom will remove the hydroxyl group, and from the beta carbon atom the hydrogen group will be going to get removed off, and thereby you are going to obtain the olefin so called as prop 1N. Okay, this is the first example. Let's understand the second example over here. Now for second example, I'll write down upper side. Now suppose in second example, first one was general reaction. Now this is the second example. In second example, instead of writing in carbon number 2 with 1 hydrogen, I'll substitute with 1 group, alkyl group, right? So let's substitute that with 1 alkyl group. Let's understand that by substituting with another group over there. Now this is same structure I am drawing over here. Same number of carbon, same structure. Let's draw the same structure over here. Okay, but in carbon number 2, what I am doing is that in carbon number 2, 1 hydroxyl group I wrote, but instead of writing 1 hydrogen, I am going to keep or substitute with 1 methyl group, right? So with 1 methyl group I had been substituted over there. The name will be going to get varied or with 1 derivation over there, and name will be as such. Now in second, now 1, 2, 3, right? 3 carbon. But in second carbon, you can see 1 group has been attached. Which group? Alkyl group. And the name of that alkyl group is methyl group. So the name will be as such 2 methyl, means at second carbon the methyl group is attached and the parent alkane is propane, right? The parent alkane is propane, prop N. E, instead of writing in, what I am going to write? 2-ol, because propanol is there, right? 2-ol. At second carbon atom, methyl group is there and ol group is there. So the name will be 2-methyl propane 2-ol, right? So this becomes the name for this reactant wherein we have taken in the form of alcohol. Now in this, if I add the dehydrating agent so called as sulfuric acid, I am adding the dehydrating agent, and you know that from alpha carbon atom. Now which is the alpha carbon atom, by the way? The carbon atom at which the OH group will be there, right? So the neighboring to the carbon atom, alpha carbon atom, there will be the beta carbon, obviously. Now the beta carbon I am going to consider this one, beta 1, and this is beta 2. Okay, now here from alpha carbon atom the OH group will be going to get removed off. Yes, you know that. And from the beta carbon atom, now it's your choice, whichever beta carbon if you want to withdraw the hydrogen atom from beta 1 or beta 2, the product will be the same. It will have prop 1 in only, right? So now from beta 1 I am going to remove 1 hydrogen atom over here, right? So both the groups are going to get detached or eliminate from it to form an alkene. So once they have been eliminated, they will combine together to form water molecule. The hydroxyl group and the hydrogen group, they will combine together to form a water molecule, and whatever is left over there, they will form one olefin or alkene. Okay, so let's write down the alkene which has formed over there. 3 carbon atom. Okay, let's draw this 3 carbon atom one by one. Now in carbon number 3, nothing going to get removed off. So I am going to write down carbon number 3 as it is. Now in carbon number 2, what was getting detached over there? Alcoholic group, OH group. So methyl group was as it is, right? So the methyl group I am writing as it is upside. Now what was getting removed was the alcoholic group, the OH group. So this bond will be going to get shifted over there, right? So once the alcoholic group has been removed from there, the bond will be going to get break, and here the double bond will be going to get formed when these two groups will be going to get detached from it, and you will get an alkene formed between, or in form will be going to get between carbon number 1 and carbon number 2. Then the carbon number 1 will be going to get balanced by getting attached with the another 2 hydrogen atom which is there, right? So this is how the structure of the alkene will be going to get obtained, and the name of this alkene or olefin which has formed over here, let's write down the name for this. The name will be, yes, in second carbon what was there? Methyl. So the name will be 2-methyl, yes, propene is there, but at which position the double bond is there? Carbon number 1 and carbon number 2. The lowest preference what I am going to take? 1. So it will be 2-methyl prop 1 in will be the name of the olefin or alkene which has been obtained by dehydration of alcohol from that. Okay, now let's take the another example which is applicable by taking the Sedzef rule over there. Okay, now let's understand the Sedzef rule which is needed to be applicable for the dehydration reaction, basically in elimination reaction. So how this Sedzef rule will be going to get applicable in this process, let's understand by taking the example. Now I am going to take the fifth example with the 4 carbon atom into that skeletal formation. So let's take this 4 carbon atom, let's draw this 4 carbon atom first. 1, 2, 3, 4. Okay, now if this is 1, 2, 3, 4 like this, I want at second carbon atom the alcohol group should be present, right? So this Sedzef rule is applicable in dehydration of alcohol, right? So how this is applicable, that we are understanding here. So at second carbon atom the alcohol group is present, then the remaining carbon atom will be going to get balanced by getting binding with the number of hydrogen atom. Okay. So the carbon number 3 will have 2 hydrogen, carbon number 4 will have 3 hydrogen. Okay. Now if this is there, now let's understand the dehydration which is taking place in this molecule over here. The name for this molecule, yes, obviously the name for this is butanol, but since it is present at carbon number 2, the alcoholic group or the functional group is attached over there, the name will be butane-2-ol. Butane-2-ol will be the name for it. Now this butane-2-ol will undergo dehydration in presence of dehydrating agent which is sulfuric acid. Now the sulfuric acid has to be added over there in order to break the bond between them. Now the carbon atom towards which the alcoholic group will be attached, that is considered to be the alpha carbon atom, and the neighboring one will be considered to be the beta carbon atom. So carbon number 1 will be beta and carbon number 3 will be also considered to be a beta. Now carbon number 1 let's consider to be beta 1, carbon number 3 I am going to consider as a beta 2. Okay, now once the naming has been given over there, let's eliminate the hydroxyl group and hydrogen group one by one over here. Now I am going to eliminate the hydroxyl group from the alpha carbon atom first and the hydrogen group from the beta carbon atom. Now first I am going to eliminate the hydrogen group from beta 1. Okay. So one by one we are going to eliminate over here. So if I am going to eliminate the hydrogen atom from the beta 1, what will be the product will be going to get formed, that we are going to write down. So water molecule will be going to get removed off. Yes. How? Hydroxyl group will get attached with the hydrogen group over here. Now here let's draw first carbon, number of carbon 1, 2, 3, 4. Okay. Now 4 carbon atom, the hydrogen has been removed from here, so the bond will be going to get broken over there, and it will form double bond between carbon number 1 and carbon number 2, no doubt over there, right? Because if these two groups are going to get detached, here the single carbon atom will be going to get converted into double carbon atoms over there. So they are going to get converted into doubly bonded carbon atoms, and the remaining hydrogen atom we need to get binded or attached towards the number of carbon atoms which are present over here. So carbon number 1 will have 2 hydrogen atom, 1 and 2, right? Because from this is considered to be the beta 1. From beta 1, 1 hydrogen we removed, and from alpha we removed the hydroxyl group over there. Then if the hydroxyl group has been removed, what is left over there in carbon number 2? Hydrogen. Remaining is, write down remaining as it is by balancing the valency of the remaining carbon atom. Okay. Now if this is the case, what will be the name for this compound or the product or the alkene which has been formed over here? Because from the single bonded compound it has been converted into double bonded olefin over here. So the name for this is, since 4 carbon is there, since 4 carbon will be present into this product, the name of this alkene will be butene. The name of this alkene will be butene. But depending upon the position of the alkene, the double bond over there, the numbering will be going to get varied over there. So but. Now it is, since it is present between 1 and 2, the number will be 1. The lowest preference we are going to choose over here. So but 1 in is the name of the product. So 1 we have eliminated, okay, 1 we have eliminated the hydrogen from the beta 1. Now next product we are going, now here 2 products are going to get formed. 2 products we are going to get formed, because hydrogen will be going to get once withdrawn from beta 1, and in second product the hydrogen will be going to get removed from the beta 2, right? So once the beta 1 is removing the hydrogen atom, you will get the product so called as but 1 in. Now suppose if from beta 2, the hydrogen atom is going to get removed off, or eliminate the hydrogen atom over here, what will be the name of the product which is going to get formed? Let's see over here. So from beta 2, the hydrogen will be going to get withdrawn. So 4 carbon atom. Okay, now 4 carbon atom we have been formed. Now the elimination is taking place between which 2 carbon atom? Carbon number 2 and carbon number 3. Yes, carbon number 2 and carbon number 3. So from carbon number 2, the hydroxyl group is going to get removed. Carbon number 3, that means from beta 2, the hydrogen group will be going to get removed off. So from both these 2 carbons, the elimination is going to get happen of those 2 groups. So thereby, yes, double bond will be going to get formed between carbon number 2 and carbon number 3. Then the remaining one you need to get balanced out by writing down the number of hydrogen atom over there. So carbon number 1 will have 3 hydrogen. Carbon number 2 will have 1 hydrogen, because 1, 2, 3, 4, right? Similarly here also 1 hydrogen. Then carbon number 4 will have 4 hydrogen over here. In this manner the compound will get its structure in this manner. Now the naming will be as such. Now 4 carbon atom is present over here. The name of this compound will be butene, right? Obviously butene will be there, but now in position is different over here. In means double bond position is different over here. It is present between carbon number 2 and carbon number 3. So lowest preference we are going to take for is carbon number 2. So the name will be but 2 in is the name for this product. Okay. So here also the water will be going to get formed. Okay. Now this 2 product has been formed. In first one, if hydrogen is getting eliminated from the beta 1, you will get the product so called as but 1 in. If hydrogen is getting eliminated from the beta 2, you will get the product with the name so called as but 2 in. So if these 2 products is formed, then which will be the major product and which will be the minor product, who will decide? There is a one rule called as Sedgwick rule. Now this rule is applicable to predict out of these 2 products which will be the major product, means 80% of the product which is formed, that is considered to be the major product, and 20% which has formed, it is called as a minor product over there, right? Or the lesser proportion product which has formed, it is considered to be the minor product over there, right? Now this, what does this rule says? Let's understand this rules. Now this rule says that if carbon-carbon double bond is present over there in that alkane, now between that carbon-carbon double bond, the product which has formed, if it is having greater number of alkyl group is present between the doubly bonded carbon atom, that product is considered to be the major one. I repeat once again this statement. What this Chedzev rule is saying, between carbon-carbon double bond compound, the product in which greater number of alkyl group is formed, greater number of alkyl group is present, that product is considered to be the major product, right? So suppose this is, okay, now this is the compound. I will give the one example, then you will understand more precisely over here. So if this is the compound, okay, this is the compound with the one alkyl group, and here two alkyl groups are present. Okay, now if suppose this is carbon number 1 and carbon number 2, suppose this is there between the carbon-carbon double bond. Now here nearby carbon number 1, one alkyl group is there. Nearby carbon number 2, how many alkyl groups are there? Two alkyl groups are there, right? Now this is one product which has formed. Now let's take the another one, another product. This is the first product, okay, first product. Now if I take the another product with the another alkyl group, okay, now only one alkyl group is there, okay, I'll substitute in this manner, only one alkyl group is there. Here in this product only one alkyl group is there, and in this product there are three alkyl group which is present between the carbon-carbon double bond. In first product, if three alkyl group is there, in second product, if only one alkyl group is there, the first product is considered to be the major product, because greater the number of alkyl group present between the carbon-carbon double bond, that product is considered to be the major product. Now in second product, only one alkyl group is present over there, that means it is considered to be the minor product. So let's understand from that point of view, you will understand more precisely over there. Now here in but 1N, what is happening over here? The carbon 1 and carbon 2, here the double bond is present. Between carbon number 1 and carbon number 2, the double bond is present. Now here the number of alkyl group present in this product is only 1. How come 1? See here, carbon number 4, here 1, 2, 3. So this is the methyl group. This is the one alkyl group. Only one alkyl group is present over here. Whereas in product 2, you can see one alkyl group. This is one methyl group, carbon number 1, CH3, and here also CH3 is there across the double bond. So you can see over here, across the double bonded carbon atom, if that product is having greater number of alkyl group, then that product is considered to be the greater, major product. So in but 1N, only one alkyl group is attached. Here any alkyl group is there? Here only one alkyl group. You cannot consider this as alkyl group CH2. No, CH3 is an alkyl group. Now, but in second product, here CH3 is there. Here again, here CH3 is there. So carbon number 1 and carbon number 4, you just focused over here. Carbon number 2 and carbon number 3 is the double bonded carbon atoms. So carbon number 1 and carbon number 4 is having, alkyl group over there. They itself are the alkyl groups. So it says this product is the major product. Yes, but 2N is considered to be the major product, but 1N is considered to be the minor product, and that is decided by whom? Chedzev rule, which says that the alkene which is formed by the elimination reaction between carbon-carbon double bond, if that product is possessing larger number of alkyl group, then that particular product is considered to be the major product, then the remaining one will be considered to be the minor product. So this is how the dehydration process will be applicable by having Sedgwick rule, and this Sedgwick rule will be applicable after butane, but2ol, or after butanol, whatever the group will come, there the Sedgwick rule obviously will be going to get applicable over there, because two products you are going to get obtained over there, and after those from that two product, which will be the major and which will be the minor, that will be going to get decided by the Sedgwick rule itself. Okay, now we have been winded up with the dehydration of alcohol in this session number 4. Apart from that, we studied what is an alkene and the 5 members which are belonging to the alkene family with the general formula so called as CnH2n, and we emphasize upon the most important topic, which is the dehydration of alcohol. Means here from the alcohol the water will be going to get removed. How the water will be going to get eliminated? Here the alpha carbon will remove hydroxyl group, the beta carbon will remove the hydrogen group, and thereby whatever the product you are going to get over there, that is the alkene or the olefin. Now if suppose two product is formed over here, that time the Sedgwick rule will be going to get applicable, and this is that across the carbon-carbon doubly bonded compound, the compound or the product in which greater number of alkyl group is there, that product is considered to be the major product, right? I had given one common example I had given, that is not there in your textbook or in your syllabus. That was a common example which I had given, but now here how it is applicable you can understand from this reaction itself. So we will wind up with this session number 4. Now in session number 5 we will begin with a new concept, that is preparation concept only, how you can prepare the olefin by taking certain process. So children, these are really very interesting reaction. You need to thoroughly go through and practice well while writing down this reaction. Then only you will understand more precisely over there. So thank you class for watching this class. Thank you so much.